I'm still gonna assume people are looking in this direction and taking notice. If anybody starts snoring, the person next to them yell at me, so I make it a little more interesting. What I'm going to talk about today is innovations we've seen in mobile performance ad fraud in the past year. So 2017 was a super interesting year for me because finally things happened and fraudsters actually came up with new ways of defrauding our advertisers. That was very good. And let me jump right in. So the first thing that we had in the past is fake installs. Fake installs are a thing that has been going on since mobile was incepted and are a direct descendant of what we would call fake conversions in the mobile in the desktop web days. So when we're talking about fake sales, fake leads, things like that. So what we have here is mostly automated, scripted generation of either curated or automated data that is going to be pushed in a system through the means of actually using the technology. So in our case, as a tracking provider, people would actually create installs either from emulation or from devices that are not being used by real users but are being used by software scripts to generate installs and post-install metrics like retention, like reaching certain events inside of an app. And usually that is pretty easy to find out because that traffic has a lot of things in common. So most of that traffic would come from anonymized networks. Most of that traffic would come in very similar sequences for each of those installs. So we would see the same behavior on all of those installs with the same patterns, the same frequency of interaction. And usually that is pretty easy to find out and pretty easy to get rid of. With spoofed installs, the step that was taken was gigantic. So what the fraudsters did here is they went away from two major things. First off, they actually didn't use our technology anymore. And that doesn't go so much for us as in Adjust, it goes for us as a tracking platform. So that same thing is happening to all the other providers as well. And all of them also secured themselves against it. So what is happening here is that the technology is being completely misused by actually figuring out how it works behind the scenes and attacking it right at that moment. And then the next big step in the evolution was that the fraudsters went from not using curated or randomized data anymore. They were actually using real, legit data of live devices that were active the same day or will stay active for a longer time. How did those guys get there? Most of the things are shrouded in mystery because a couple of things we can't really look deeply into, as in who is actually doing that, because since most of our advertisers work with blind networks, it is not possible for us to actually find out where the money goes in those fraud schemes. And usually those networks aren't very forthcoming when it comes to opening up who they actually pay the money out to. But what we do know is certain kinds of attacks on how they're technically done. And one thing that we know for certain is that those guys use proxy software, something like Charles Proxy, which some of you might know, to break open the SSL encryption by actually instigating a man-in-the-middle attack between the app that they want to defraud and the server of the backend system of the app developer, as well as the backend servers of the tracking platform. And what they find when they do that is which URLs actually get fired and which data gets transmitted to those backend servers. And when you figure out which data gets transmitted, the next thing is you repeat those penetration attacks or penetration tests a couple of times, and then you figure out, okay, which parts of those URLs are static, which parts are dynamic. For the static parts, you just keep them because they work for every install. The dynamic parts, you want to change accordingly to the data that you actually want to transmit. And as I said before, in the beginning, people actually used either curated data that they had in a database from somewhere. Either they bought it or they recorded it themselves, and they used old device data, or they randomized data out of data that would look legit if not put under scrutiny. But what they did to improve on the whole thing is they actually came into the domain of having real apps out there on people's devices. And now here's the first mystery. We don't know if those are apps that are specifically designed to do it, or if that is just apps that have no idea it's happening to them because it is some SDK that is within the app that is doing the thing. Well, what is happening is in those malicious apps or hijacked apps, all the device data for this device gets recorded, which is nothing malicious in itself. Basically, every app does that. And that data is sent back to the backend system of the fraudsters, and then they generate the URL that they need to fire in order to spoof an install. And then they attach all the device data of this real device that they just grabbed. So it's definitely fresh and valid. And then they send that URL not directly to us or to the backend service that they want to spoof, but they actually send that call back to the device, to their own app, and have that app execute that URL. So now whatever backend system gets hit sees a request that has that system record and install, that has data from the device that they just got the request from. So from a server standpoint, from a connection security standpoint, everything looks super legit and everything matches. So that thing would actually be attributed. To get rid of that, what we did and what everybody else did as well, as far as we can tell, is implement a signature feature into our SDK, which makes sure that for each request that the SDK sends back home, we have an encrypted, actually a hashed signature attached to it that our backend system can replicate, but nobody externally can replicate without knowing the shared secret between us and the app developer. And that means that now those session requests are secure. Unfortunately, nobody had something like that before the end of 2017, which means that all the apps out there that right now run unprotected, especially apps that have their own tracking and that don't use a platform that does the tracking for them, are very likely to be defrauded in that way. And the explosive growth that we've actually seen around this fraud scheme is quite impressive. So we actually saw advertisers that only started advertising their apps in October, and they started in the beginning of October, and by the end of October they were already seeing 70% installs being spoofed. And that unfortunately doesn't only go for the paid, it also goes for organics, because those guys want to not just line their pockets, they want to line their pockets for a long time. So they actually spoof growth, not just UA success. So they make sure that the app developer thinks their app is actually booming out there in the market when it's not. The one way to actually figure out if that is happening or not, actually a no-brainer, unfortunately, something that sometimes needs to be brought up, is that you definitely need to check against your App Store numbers, right? If Google Play Store or iTunes tell you there was 10,000 downloads, then there was most likely 10,000 downloads. If your backend system or your attribution provider tells you it's 100,000, then it's definitely worth checking out where that discrepancy comes from. Unfortunately, in some cases, people were just determined on thinking they are having success when they didn't. So that is a very I'm looking for a very good superlative, and I can't find one. But it's a horrible fraud scheme. It's very hard to actually figure out that it's happening. And Unfortunately, the spoofers have become so good over the past year that by merely looking at the data that is coming in and trying things like unsupervised machine learning to find the clusters in the data that comes in is not good enough anymore, because they're actually sending real life device data. So you can actually check that against other installs that you're seeing. Well, we could do that on our platform, and we would see, yes, that is a real device that is actually showing real usage in other spaces, just not in this one. And the user and the device of the user are not at fault, right? Mostly the user has no idea that it's even happening to them. And that is the evolution step from fake installs to spoofed installs. The next big thing that we're actually having, and I'm not even sure if that is the bigger of the two. We're still trying to figure out what the impact is of the two evolutions side by side. Bear with me for a second. Sorry. From click spam to click injections. So click spam is basically the granddaddy of mobile fraud, period, right? Click spam has been there like 1997 when the first advertisement on the web actually happened, and everything was paid on a per click basis. Click spam was one of the first things that appeared to defraud the budgets that were spent there. There has been some evolution in click spam, and click spam moved to mobile, and click spam survived the change to what we would call performance marketing, where people actually thought, well, if you're not being paid for the click anymore, it doesn't pay off to actually spam clicks, which was pretty much an oversight of a logical nature, because the click spammers right now cash in on the random chance of somebody that they spammed the click upon actually converting for the offer that the click was spammed for. So if you have a mobile website and you have a user visiting that website and consuming content, in the background, clicks would be spammed like crazy for each and every different offer that the fraudster could get their hands on. And if that person then in the next couple of hours converts for any of those offers, then you cashed in on the random chance of exactly that happening. The conversion rates that we're talking about in old school click spam, so click to install conversion rate on mobile, would be somewhere around 0.03% on average. Unfortunately, on 0.03% conversion rate chance, you can still make a pretty good buck every month if you have 500 million unique visitors a month that you can spam your stuff on. And the same is true for the time when click spam actually went to in-app native, which is also a thing that has been going on for at least 5 years now. And the whole thing there is a bit more nuanced. The spamming is not as brute force. It is more targeted, since just an app has more information about the user. The app knows which apps are already installed on the device, which apps are constantly used, when were those apps installed, all that data is available. So you don't have to spam clicks for stuff that is already on the device. You don't have to spam clicks for things the user is constantly using. You would, though, spam clicks for things that the user is likely to be using. So they're taking the same approach as any marketer would in properly creating an audience and trying to cater to it. Click injection, however, is actually refining this whole idea to a much better level. So with click spam, you have that problem, random chance of distribution, of conversion is not something that you can plan very well. You can lose access to your top driving campaigns, and then your conversion rate is actually going further down. All of that affects revenue, and since fraud in the digital ecosystem is not a couple of unwashed people sitting in sheds somewhere, this is actual business, right? They have to make sure that their revenue streams stay constant, intact, and there's growth, because everybody wants growth, even in fraud. And click injection provides a solution for all of that. So instead of spamming as much as you can in the chance of in the hopes for a random chance of conversion, what is happening here is a click actually gets injected after the user made the conscious choice of downloading and using an app. Now this is brilliant because since that user already made up their mind, and it's completely irrelevant if that user made up their mind because a friend told them, or they saw a billboard ad, or they actually saw a mobile advertisement that should actually be paid for, the fraudsters here steal that attribution under the nose of everybody because they inject the click last, and since the last click wins, they come out on top every single time, no matter how good the advertisement was before. How are they doing that? Good news, it only happens on Android. Both exploits that the fraudsters use here are Android operating system features that have been misused for fraudulent intent. Both of them actually have a good reason to be there. They're not as secure as we would like them to be, but Google actually reacted to that whole problem and created a bit more secure system. But they can't close it down as much as they want to because they are an open platform. But what is being used is two specific operating system features. One is what is called the Android content provider, which is basically an SQLite database that runs on the operating system and that holds all the information of downloads from the Google Play Store. So as soon as you click the download button in the Google Play Store, that database will get a new entry that says this app with bundle identifier, name, download size, and everything that the operating system needs to show you how far along the download is being downloaded. And any app on that Android device can subscribe to that information, which means they don't even have to listen or trigger for it to get the information. They will actually be notified from the Android operating system, hey, this new app is being downloaded. Now, any malicious app on the device can take that information, either send it back to their home server and get an answer of, yes, we have an offer for this, execute this link, or it might be cached in the app already. Doesn't make a big difference. The thing is, with that information of this app being downloaded right now, you can already inject a click right here. And this will be definitely a click that happens after all the real advertisements. So attribution will go to this click. Also beautiful, since you inject that click at the beginning of the download, everything is going to look super legit when you're trying to figure out click to first open times or click to install times. Everything is going to look great because all that time still has to pass. The download needs to finish, the install needs to finish, and the user still has to open the app. The second exploit that is out there is what we call the broadcast or package edit broadcast exploit. Again, Android operating system feature, whenever a new app is installed on the device for the first time, there's a broadcast to all other apps that tells them this new app has been installed. The idea behind that is that every other app can now communicate with that new app without you taking any action. So let's say you have the LinkedIn app on your device and you download the Slack app. Without ever opening Slack, without tying those two accounts together, you can go to the LinkedIn app and say, I want to share this article, and you will have the Slack app in the selection, and you can go, which is the intended purpose. Now, the fraudsters can do the same thing as they did with the last exploit, right? They find out which new app has been installed, and then they can use that information to inject the click that they have either cached or get from their backend system after the app was installed, and hopefully before the user opens the app for the first time, because that is the cutoff point for all attribution systems. Now, this second one has the advantage of being, again, later in the game, which means it's closer to the first open, so the chances of this click seeing the attribution is high. On the other hand, the problem is in a statistical distribution of click to first open times, or click to install times, as people call it. This is actually something that you can find, right? Because you see a high distribution of very short click to first open times, especially users that open the app right away when the icon hits the home screen will create installs that look like they converted from click on the advertisement to first open of the app inside of a couple of seconds. So that is, statistically speaking, something that is an outlier that you can find, but you can't actually do anything about it. Again, the evolution in 4 points from random chance to injection after the user made their decision. The targeting is not needed anymore because you exactly know which app has been installed. You can't identify the whole thing from a conversion rate standpoint anymore. When they use both exploits, you can also not rely on the click to first open time distribution anymore. And it's not something that you can filter out on a statistical method properly. So a lot of networks and a lot of our competition would actually tell you, well, if you look at the click to install times, just cut out everything that happens in the first 30 seconds and you're going to be good. Sorry to burst that bubble, that is a flat out lie. That is not solving anything. So what you actually would need to do is get to the deterministic version of getting rid of that, right? We have our 2 exploits, the broadcast exploit and the content provider exploit. That's the 2 points in time when those clicks can be injected. And Google actually made available, is this thing working? Let me see. Yes, awesome. Can anybody see that? Does that work? Yes, awesome. So the install finish timestamp is available from Google, and the app download initialize timestamp, so when the user clicked the download button in the Play Store, is also available from Google. So either the app developer themselves or the attribution platform can make sure that those 2 points in time are recorded as a timestamp, and then what you would do is exclude attribution of an install to a click that occurred after those 2 timestamps, solving the whole injection issue in one go without having to rely on the statistical method of trying to figure out, okay, what is a reasonable download time for my app. And that actually concludes this whole bit. If anybody wants to talk, I'm going to be around. I'm going to have an open question round right here. I'm going to be outside afterwards when the next talk starts. And also, you can definitely find me on LinkedIn or contact me through Adjust.